Hi, everyone, and welcome to week 5 of Math 201. In this module, I am going to talk about how most of you did on the exam and address a couple of things that you may have struggled with on the exam, and then also dive into what you're supposed to cover by the end of this week. So overall, the individual performances on the exam was good. A couple of areas where I found you were having some issues with is one, when it comes to finding the derivatives for exponential functions with a base e, and then also differentiating logarithmic functions. Another area was using the product and the quotient rule. And finally, was determining which functions are differentiable using graphs. So I put a couple examples here that I want to go over briefly, but you can always go back to the slides that I've provided and the extra materials that are in the course. So if you have examples like these here where you are given functions like to the base e and then ln of x, we can easily find the derivatives here. So the y dx of the function that we're given 3e to the x will then be, since 3 is a constant, we pull that out, and then we find the derivative of e to the x. And the derivative of e to the x is still e to the x, and so you have 3e to the x. In this case, we can do the same, dy dx of x squared e to the x becomes, in this case, since you have x squared multiplying e to the x, we can use the product rule. So we have x squared and then d over dx of e to the x plus e to the x and then d over dx of x squared. And so we have x squared e to the x, since the derivative of e to the x is the same, plus e to the x, the derivative of x squared will be 2x. And we can rewrite this as ex x squared plus 2x. For this function here, we have x cubed. The derivative of ln x is 1 over x plus ln x times 3x squared plus 4. And then this just gives us x squared plus 3x squared ln x plus 4. And then for the logarithmic function, if we have a function like this, we could rewrite things as ln x over ln 3. And also when we take the derivative in general of log x to the base a, we have 1 over ln a times 1 over x. And then also d over dx of a to the x is also ln a times a to the x. So in this case, we have y equals 1 over ln 3 times 1 over x. And so we have 1 over x ln 3. We could also look at another example of the product rule. So we have this function multiplying this function. And in general, the product rule is given by, so f prime of x equals f of x times d over dx of g of x plus g of x times d over dx f of x. And so f prime of x in this case will be x to the fourth, and then we can find the derivative of ln 9x plus ln 9x times again the derivative of x to the fourth. And so we have x to the fourth times 1 over 9x, and I already went over what the derivative of ln x would be times, this should be 9 and not 9x, plus ln 9x times 4x cubed. So we can cancel out 9 and then x, and this gives us x cubed plus 4x cubed ln 9x. So that's how we can solve an example using the product rule. So we can also look at the final parts where we use graphs to determine whether functions are differentiable or not. And the conditions that we look at here is that one, there is a continuity at x equals a. So we can take a look at this example here where we have some function g of x. And so g of x in this case is not continuous at -2 from our graph. And so g of x is not differentiable at x equals -2. We can also look at the fact that there is a corner at x equals a, which is what we have here in these examples as well. And then we can also look at the fact that there is a vertical tangent at x equals a. So when we say a function is not differentiable at these points, then we want to take a look at these three conditions. That one, there's discontinuity at x equals a, there is a corner, or there's a vertical tangent at x equals a. For this week's module, you will be looking at the sections 3.1 to 3.4, where you use the first and second derivatives to sketch curves and solve for optimization problems. You'll also be looking at how to sketch functions using the calculus that you've learned so far in terms of the derivatives. And then we'll also be looking at how to determine asymptotes of a graph and graph rational functions. So some of the examples on the slides I've worked out using examples from your homework assignment. So if you need help on the homework, I'll say that will be your first go-to. But as always, you can reach out to me if you have any questions or concerns. But these are pretty interesting concepts that we are going to review for this week. The assignments you're supposed to complete include all the homework assignments in Module 5, which includes the A and B parts of it, the quizzes, the check-in quiz as well. And then you also have a discussion about how the midterm was for you. Like I said, the overall individual performances were good, but I suspect a few of you may need assistance here and there. Please do reach out in that case. If you also need additional resources, feel free to reach out to me. I try to make sure I provide extra materials, but if you need any additional resources, please reach out to me. I hope you have a wonderful week. All the best.